Let me show you what I'm working on today. So as part of the Mk2 version of this product, I'm making a little power supply protection add-on that will go on the PCB just behind these capacitors. And in order to do that, I'm going to use a TVS diode which will provide shunt protection. So when the voltage at the input gets too high, it'll clamp it and draw lots and lots of current. And for series protection, I'm using a resettable fuse. So these two together will essentially work like a kind of clamp and stop. And when the voltage gets too high, you'll get lots of extra current through the TVS, which will blow this resettable fuse temporarily, so the thing doesn't die. And basically what I've got to do today, or what I have done today, is I've had to work out what sort of current rating I need this resettable fuse to have. And in order to do this, I have to sense the idle current of this unit using a series resistor of about 100 milliohms in line with the power cable, and a true RMS voltmeter, because this thing is an AC power supply and the current draw is about as linear as the output of your average British valve amplifier, for instance. So this type of meter, it's absolutely no good for this type of thing. It'll give you too low a reading and you'll select an inappropriate value and the thing will just blow as soon as the unit's switched on. So let's switch it on. Let's go. So you can see we get about 13 millivolts RMS, which translates to 130 milliamps across this 0.1 ohm resistor. Fantastic. So we've got an idle draw of about 130 milliamps, but we also want to work out what the maximum current draw in any given situation might be. And in order to do that, I've made some taps off the power supply section of the circuit in this product, and I've also got this resistor here, and we can work out what the maximum current draw might be in the worst case scenario. In this case, I've selected the resistor to dissipate about 600 milliwatts of power, which is about as much extra margin as you would need. In practical tests that I've done on this, it only consumes about 300 milliwatts more in the worst case situation, so this gives us quite a comfortable margin. And you can see now the current has increased to about 250 milliamps, which tells us that what we need is a 250 milliamp resettable fuse. Fantastic, easy life. That'll blow at about 500 milliamps, which means that the dissipation through this TVS diode, when that happens due to an overvoltage fault, will be about 7 watts, which is quite a lot for such a small component. But you've got to remember that it's only for as long as the the resettable fuse needs to blow. So 2.5 seconds, we can handle that. Easy life. And then once it blows, what will happen is the idle current draw of the unit itself will then keep it blowing. So the muting circuit will turn off and the thing will basically go dead, and you unplug it for a minute and then it'll come back once the resettable fuse has cooled down. Easy life. So there you go. That's about it. Back down to 130 milliamps. Perfect. Take care.